I'm here with Greg at Yarra Ranges Tech, and you can explain a bit about how you develop some of your modules here for STEM.
Yeah, sure. So we start with a constructive statement or a challenge statement where students are presented with the challenge. So in this case, pipes frequently become blocked due to tree roots penetrating pipes, build up of fats or oils, litter and debris or damage and broken pipes. When blockages occur, they must be dealt with promptly. You've been asked to design a robot, etc. So that sets for the student the basic challenge requirement. What we then do is see that we break that down into what are the key elements. In this particular case, there's 3 key elements: to crawl through pipes, clear pipes, and find inspiration from nature. Further to that, there's some topics which we would expect that the students would be introduced to, and that is sustainability, biomimicry, and insect locomotion. The last 2 relate to the technologies that we're trying to therefore introduce the students to, and it's this where the critical part of the work that we do is trying to bind the technologies into otherwise the broader context.
Cool.
We do that by taking the preferred or the planned session plan and looking at the elements that are going to be required to make that run from end to end. Then using the elements and the topics that we've identified, which again, both the elements of the challenge and the topics, including the technology and the content, and we then proceed to map the distribution of how each of that, or how that fits in the same way that you do a curriculum mapping exercise. And we can see here what the distribution and what the coverage of the various aspects of the challenge is.
Thank you. And so you've taken an idea and you've actually building on it. And we started off with the idea of a robot that can help clean pipes and tunnels. And then the students will be able to look at some inspiration in nature for doing that. And you're obviously covering up a number of topics: so sustainability, biomimicry, insect locomotion, and the Arduino and the VR. And then do students actually, how do they finish the project when they're finished working with it?
So the work that the way that our students finish is they'll end up giving presentations. So if we look at the challenge, they start with the understanding of the background area of these topics. So they're introduced to those 3, and they finish with being able to give a presentation and justification of an open design that they've done using that technology.
Great, and we've actually got one of the robots here. Explain a little bit about the robot.
And so what we've done here is this robot here has the ability to be kicked off, and so it has a sensor. There's a number of buttons here we can just press on, and when the students go through the first part, they'll actually be given, if we go back to the screen there, this is mapping going through the first P1 through P4, how to make this robot function. And then once they know how to make the robot function, they'll go into the open design, which is over an hour of them experimenting with the robot to expand its functionality. And to summarise, as you said, how they finish off is to give a presentation and justify the decisions that they made, the choices that they made, the designs that they made in that open design, having been given access to or being encouraged or stepped through the basics of how to get the robot to move.
Thank you very much, Greg.
Thank you.